Thank you, Adrian, for the introduction. Just like to take a few minutes to let the panelists introduce themselves, and then we'll kick off with some interesting questions, I hope, on storage.
My name's John McCudden. I look after the Renewables business at Empower. We design and build various types of power systems. In the oil and gas business, the commercial emergency power, and also renewables and energy storage. So I guess more pertinent to this conference is the work we've done putting some energy storage systems in remote sites in the Northern Territory. We built a solar farm at Weipa for Rio Tinto, and most recently finished a behind-the-meter energy storage system at Karratha Airport, where we integrated some cloud predicting technology, which was some interesting discussion from the previous people on stage. So it's a little bit about me and Empower.
My name's Phil Livingston. I'm Managing Director of Redback Technologies, founder. I've been in the renewables business for 15 years in Australia, China, the US, and the Philippines. At Redback, we create enabling technologies that allow for a variety of use cases to be filled for really maximizing self-consumption of solar-generated electricity through smart IoT management and machine learning algorithm functions, as well as hardware development with storage and the like. And really, when we approach problems, we typically approach problems from the standpoint of trying to understand the core use case for the technology and how the technology can benefit that use case, principally through understanding data, consumption, behavior, this related function, and that's kind of how we're approaching this problem as well. We have some systems in remote communities. Our existing systems that we're implementing in the market typically have a 5 to 6 year return on investment in standard grids without this recent power increase in prices. So we obviously are looking towards how do we increase self-consumption for mines in non-production-based environments, more in housing and things of this nature, and how do we also find better use cases for or not use cases, but use of data to help with other aspects that mining companies operate with.
Cool, good. So yeah, my name is Jürgen Zimmermann. I work for ABB Australia, and even I've got a bit of an accent. I didn't fly in from Switzerland or Germany. I actually live in a wonderful place of Darwin in the Northern Territory. So yes, you can live there, and I lived there for the last 25 years. And it's not a matter of survival, it's a matter of enjoyment. Anyway, so just quickly, we've been focusing on microgrids, off-grid systems to start with, now grid-connected microgrids as well. And it's from ABB's point of view, it's technology and the automation that we're looking at, deploying obviously in the field.
Thank you. So I think from the last session, two of the key words that came through for me were the ability to adapt and the ability to enable. And I think one of the ways in which we can do that is through storage. I think throughout the conference we've heard some really good case studies. Storage in mines isn't new. It's already there, and we're already implementing it and using storage to increase the performance of renewables. We've heard about the DeGrussa mine. I know that some of you went on a trip to see that earlier this week. We've heard about Australian vanadium studies into using CSP and how we can use CSP as a storage means. Anel and ABB have talked us through microgrids and how they've integrated storage into those solutions. I think two of the other buzzwords that we've heard have been contribution and penetration, which are my new words of the day. And we've heard from the speakers on energy storage how they can increase those two aspects. We've also heard from the miners, I think, that the key issues for them are cost competitiveness, flexibility, reliability, and efficiency. So I think kicking off with our first question for the panel, what are some of the lessons learned from the existing projects where we've had storage?
Well, I guess from Empower's point of view, one of the key things we've seen with the job we did at Karratha, where we had some cloud predicting technology, our experience is on some sites, PV power systems can lose up to 80% of the power output in less than 10 seconds. So in those sort of environments, you need to have a lot of energy storage to be able to manage the power ramp rates. So the first couple of jobs we did in the Northern Territory where we had that sort of experience, we needed something like 600 kilowatt hours per megawatt hour peak power to manage a ramp rate of something like 12 minutes, which the operator required in that particular site. So introducing some cloud predicting technology at Karratha, where we had some visibility of what was coming, we managed to reduce the amount of energy storage from 600 odd kilowatt hours down to 300 and something kilowatt hours. So in that particular application, even though it still wasn't commercially viable, the amount of energy storage and the cost effectiveness of the solution was much improved by the introduction of new technology. And I guess that's my key point, if I have one for the conference for you, is it's not just about batteries, and it's not just about diesel generators, and it's just not about inverters. Sure, you've got to buy tier 1 equipment, you want to make sure it's reliable and it works, but it's what you want it to do and what your particular application is, and you'll all have different applications. One mine will be different to another mine, but you need to use the right equipment, and it needs to be integrated together. And in cloud predicting's case, it was introducing some new technology. So, you know, every week, every month, we're reading about someone's invented something new. So we need to look at that and see how we can use that in our systems, and to integrate that, you know, for the benefit and to drive down costs for a particular site.
Yeah.
Yeah, I also want to bring a different aspect maybe to this, and that's the human side of things. And you know, the human side of things for me always comes in through the operator, right? Whenever you talk to the operator, you get the true story. So maybe just share with you, you know, what we've experienced, not just in mining, but in utility as well. And because we've been deploying microgrids, you know, in various parts of the globe. So I picked the one actually in Portugal on one of the islands in the Azores. And I remember so well, you know, talking to this guy, and, you know, his Portuguese, you know, and English mixed together. He was trying to express actually, you know, what the main concerns were. And it was actually only through talking to them, sitting together, you know, through the night shift, and actually working through what it is that he's concerned about. And what I found is that, you know, we're so good at technology, deploying all this sort of stuff, but what we forget is to bring people along and making sure we give them enough time to actually understand and realize, hang on a second, how can I use this? How does it actually work? Because we get through this construction, we put the stuff in, we get the payment, and then, oh, hang on a second, does it actually operate the way it's supposed to operate? No, it operates it with a reduced output or a changed, you know, structure. The diesel was put online just because he thought it's a good idea to put it online. So, you know, I think what we got to learn from this is through the development and construction phase, start working with all stakeholders, including the operators, to make sure they know what's coming and how they can prepare for this. So I think that's a lesson learned, you know, how we can improve things going forward. Don't wait for the day of commissioning, handover, and then, you know, sort of have a go at it.
I think that's right. I think it's about education. I think it's about bringing people along for the journey. And I think where we see the best results is where there's that true integration of all the different counterparties and stakeholders from the get-go. Phil, I don't know whether you've got any comments to add, and perhaps some parallel lessons that we might be able to take from the adoption of storage in other sectors.
Yeah, I think we're obviously more of a novice in this kind of mines space, given that we're a startup and the like. But most of our consumers that are consuming, even in embedded networks, are achieving in excess of 85% self-consumption with our tools. And I guess in that space, with the way that we apply our technology, you know, we with the use of I guess understanding use case with data, we're able to we don't operate on like a full mine perspective of providing 100% power. We'd operate in really diesel reduction in non-production assets, and then understanding how the consumers are consuming through load disaggregation functions that gives us a better way of applying the technology. So over time, and that's really our kind of our push. We've just begun doing our first rollouts, doing microgrids, and again using solar really as our effective spinning reserve in the middle of the day with our storage capability, and we're seeing significant reductions in diesel use, over 90%. But that being said, we're not going to go completely in and provide full power. But yeah, so.
That segues quite nicely, I think, into the next question. I know, obviously, total replacement of diesel and gas for remote sites is still a challenge. So what would you say are the key criteria for determining whether storage makes sense for a remote site?
I think Jürgen's always better with me than the numbers, but, you know, I guess I've got an accounting background, and so to me, it's the numbers. I mean, I think a mine site will be like our other customers. They'll be looking at energy security and the price. And so energy storage needs to play a mix in that, and whether that means diesel can be replaced or not. I mean, the sites we've worked on in the Northern Territory, for example, we had up to 80% penetration of PV solar, and I understand that led to about a 50-odd% reduction in diesel usage. In that case, the diesel systems were still there, providing that baseload. But to me, it would come down to the economics, and I guess that's looking at each particular site and the requirements of each particular site and what renewable energy can do for that site.
And to put Jürgen on the spot, if he's the numbers guy, and I think we saw some of the numbers in Jürgen's earlier session yesterday, can we make the numbers stack up today?
Yeah, so I think we can make the numbers stack up, and you might remember we've had this, graph of showing sensitivities around cost of PV installed in one area and, cost of diesel on the other area. So we're finding, if we're obviously in a spot in an area we've got, high cost of diesel delivered as well as low cost of PV installed, yes, you can stack up the numbers and you get a good return on your investment. However, that may change, and that's all based on a 10-year sort of investment cycle. But fundamentally, it's identifying the values we can create. And one thing I'd like to sort of explain a bit more. Everyone just talks about storage and batteries, but where the cases stack up, it's not about the storage and the batteries. It's about actually stabilizing and being the generator on the network. Because as we take diesels offline, something's got to replace it, and that's at the moment the battery system. But it's not about an energy question, it's a question of being the voltage source inverter on the network to provide the same services, even better, to what the diesel was doing before. So that's our focus at the moment, because that's where we need small amount of storage for now, but lots of power in order to stabilize the networks without the diesel being online. Once the diesel is offline, lots of PV can come in. So we separate stabilizing from storage, because stabilizing allows the high penetration. Storage then comes in to extend, from daytime to nighttime, the shifting of the energy.
Thanks, Jürgen. The panelists are making my job far too easy. Another wonderful segue into our next question. We've heard the miners explain that the loss due to lost production to them far outweighs the lost cost of energy. And given the 24/7 nature of their business, how can storage ensure the reliability and consistency of power for their operations? Phil, maybe you can start with that one.
Yeah, again, it's not exactly our use case, right? So. Probably on the wrong panel, but I think that fundamentally, for us, it's about increasing the volume of self-consumption at an economically viable return on investment. I mean, today, with existing grids in the NEM, for example, we're achieving return on investments that are highly rational for consumers to switch over. So, in mine sites operating with diesel, it's where energy is much more expensive. It becomes even more rational to add more batteries and/or to use IoT-related devices on site to maximize self-consumption of hot water and other related functions in the middle of the day, so that you're using solar for that and not having to get a round-trip cycle through storage. Rely on ABB or others to give you other functions for operating 24 hours a day and the like, but for us it's about increasing self-consumption and not applying technologies in a non-economically viable form, but rather getting to ROIs that are well sub 5 years to make this decision easy. And using the data as well, which is the one thing we're not going to probably talk about on this sheet, for other soft things like understanding the health of the workers who are consuming through flexible data and analytics on site, so that you're knowing whether workers are up in the middle of the night or what types of appliances they're using. This kind of thing can form intelligences around how to make sure that people are sound of mind and getting the appropriate rest to complete their duties accordingly.
Rest sounds like a good thing. I think that especially for those in the renewables, we'll all know that resource is key, and and everyone is kind of resource stretched. It's interesting you bring up technology. One of the things on my mind is the more we move away from sort of conventional diesel and gas use, and we do start to be more heavily reliant upon technology and software, how do we safeguard key 24/7 businesses against technology risk, software downtime, those sorts of issues?
Well, maybe I'm happy to answer that, but just go back one step. I mean, I just want to also clear up a myth about diesel generators. Great things, great devices, but they do trip. It's not that they're perfect, right? So, when we're comparing apples with apples, it does happen that a generator or a gas turbine can trip, and obviously that's why extra spinning reserve is provided through the other generators, and therefore we don't see an outage. So when we talk about reliability and trying to improve all the quality of supply, inverter-based systems in the past have been seen as a bit of a black box. I'm not sure what they do. I think things are shifting there as well. I mean, just on Tuesday, again, being at the Grasser mine, talking to one of the Sandfire operators there, if he had to choose between the PV online and the battery online, he would choose the battery because it gives him extra reliability and extra grunt in his network to keep things stable. So, again, there's a mind shift, and only if we get the message out there, only if we're actually installing systems, we can demonstrate and see how this actually works. So I just want to put that in as a segue that it's just not the perfect world out there. Other devices do chip, even though they do it not that often, but it actually happens that they do chip offline. So as we then, as we are on this journey transitioning from, sort of rotating machinery into technology that's very much software-based, which is true, we need to think through, from a cybersecurity point of view, from a software update point of view, how do we manage that? And, there's lessons to be learned. That's very clear. We're starting to see how we can best do it. What are the processes in place in order to make sure when we do change or when we do updates, how we can ensure that, what's delivered is actually working.
And look, I think it comes down to the design as well. I mean, you'd look at the mine site and the loads and the risk on the loads in the design of the renewable energy plant and the mix of technology that you might want to use. And then you'd come up with an overall design that you think addresses that risk, and that will have a cost. And if that cost fits the bill and is economical, then it's a go-ahead project. If it's not, then it's not. But it comes down to looking at the risk, the profile, the load profile and the design, I think.
Thank you, John. Okay, so I think what we're hearing, my sense is it can be done. It might be challenging, and it's always, going to come back to cost. I think we know that the technology can deliver, and to some extent may actually be proven to be more reliable than the current technologies and the current fuels that we're using. I was reading, give them a bit of a plug, but was reading Honeywell's pile on the payoff white paper earlier, and I know it came up in the Green Tech Media newsletter today for those of you that read Renew Economy and Green Tech Media. And those of you that don't, I strongly recommend them. The question for me here, though, is about efficiency. We've heard across the storage industry that we need to get more for our money, and that we're not really realising the full value from storage. So how can we, energy storage, transform the application of renewables for mines?
Well, I think, to me that example I used before about cloud predicting technology is one. So that's simply looking at the cost. I think the other one would be, in our experience, our applications have been more to do with managing the PV ramp control. So there've been sort of single application of energy storage. But I think from a mine's point of view, if they can use some other applications about, using the power at other points in time or giving them a bit more stability within the design of their system, that could be other benefits. But from our applications, it's been mainly about managing the PV ramp rates.
Yeah, and same. Storage only makes sense if you can connect it with all other devices, that is generation as well as loads. And that's really, I think, what we're seeing, and Honeywell talked about it in the presentation today as well. This where we see integrated mines, where we know exactly what's happening from a processing plant point of view and how we can optimize. The extreme was, yesterday when, the refinery works when basically the sun's out and then, we sort of shut down again. That's where the optimization will certainly come through. So connectivity and being able to see what other devices are doing and making optimized decisions, that's where the next, change will come along.
I think that there's often, though, when we ask this question, we forget to think about how technology has changed with regard to software, as you just mentioned in your previous question. I mean, fundamentally, the connectivity is very important, but having the ability of predicting generation and predicting load consumption out, which we do 48 hours out and then 24 hours out, to a much more granular approach, especially for our prime investor and customer, Energy Australia, for the purposes of building capability for them then to trade in financial markets, and the like, to that level of rigor, gives us the ability of then understanding the level of risk of supply and demand not matching, and then understanding how you manage that accordingly with smart algorithms that take into account many inputs, and those inputs would include things like weather and the ability of predicting. Your cloud example is not an example of storage, that's an example of software. And software has this beautiful flexible related functionality, especially with the advancement of sensor networks and our cloud computing capability. For us, we like to be connected to all of our devices via cloud. And the beauty of that is, as we get to know the use case better, we then do firmware upgrades from cloud every 2 weeks to improve the intelligence of our systems in the field, so that what might go in initially in a mining camp per se, and might have a lower self-consumption after learning the use case and learning the ability, over time will improve through algorithms getting smarter and becoming heuristic in their ability to train themselves, the data, as well as to include other disparate functions of connectivity to IoT interactive devices on site, like an IR blaster for air conditioners or other related functions, so that we provide virtual power plant demand response functions into mines that where the camp can actually provide benefits as a generator in aggregate to the mine, as well as in that flexibility. Yes, not offering complete redundancy, but still offering full UPS functionality for sites, so that at least when people have access to air conditioners and those related resources in mining camps, they're not unduly affected by a generator going offline.
And look, that's a good point you've made. The systems that we provide to manage the ramp rate are automated, so the energy storage is linked directly to the solar plant and to the diesel generator. So the message is going between each direct the battery storage system's activities. So in experience in the Northern Territory, we've found that where there are intermittent cloud days and our system is constantly putting the batteries on and taking them off and cycling them continually during a day, that on those types of days it's best just to curtail the plant for a period of time, so that the level of battery storage is there should there be a big cloud event. So you curtail the power and you lose a little bit of energy, but the outcome is, you don't cycle the battery so much, so there's a longer lifetime on the battery and the maintenance on the battery will be lower. So I think in terms of getting some history about what happens on a site, that's important, and the technology needs to be tuned over a period of time to make sure you're getting the best out of it.
And I think just taking where we ended up in the last session and bringing that into this discussion, obviously we talked about how the energy mix and innovation and technology may actually ultimately change the way the mines mine. It may change the way they operate. Their demand management is also going to be a large part of that. And I assume the software that's another thing that the software can manage, is not just the inputs from the energy side, but also the demand management, and optimize that so that going forwards we can actually get the best overall solution for the mines.
I would say that, kind of in viewing this, if we could take this back to a simplistic approach and say that from the standpoint of kind of consumer interaction, or not consumer interaction, but maybe operator interaction, is probably less efficient of an outcome in a analog sense than a heuristic algorithm that's learning from thousands of use cases and forming its own capability of functional decision making to optimize. And that doesn't mean that it can't be you can't override, but it does mean that that's the beauty of heuristics, that they have the ability of learning. Algorithms that learn over time gives you a better capability of fundamentally making better choices with data that's available, rather than an operator just turning things on and off, if that makes sense. And that's really been our focus, because we believe that, in another complete industry vertical, in residential applications, the the conservation movement's failed, and people turning off lights when they want to or not, on the basis they're not lights, but maybe other appliances and things of this nature, doesn't really happen. So what's better than that is creating a heuristic that does it for them to a much greater degree of accuracy than what they can do on their own in an optimized and automatic sense.
I've got a slightly different view to the one you said, though, about maybe the mining industry will change to fit in with the renewable technology. Really, I think that the onus is on all us in the industry, on the technology side, to understand the technology, but then it's really to deliver value to the mining industry or any other industry for that matter. So I think, you know, we understand how it works, or how it should work, or how it could work. And it's really talking to you all about what do you want to achieve. Each site might have a different need. So what is it? How can we make this technology work for you? And if we need something else, we'll find it. And you know, you need to use the right quality equipment, but it's how it's all put together. So I think, you know, like everything, technology changes some things you do. But I think from an industry, it's more the renewables fitting into the way the mining sites need it to work for them.
I take a bit of a different viewpoint as well here, and that is, you know, obviously renewables at the moment are the disturbing part that's coming into a mining operation. Now, mining operation at the end of the day is like a vertically integrated utility. However, you know, the distribution guys don't talk to the retailers, they don't talk to, you know, the generators and so forth. So one of the things I think we see from this conference is, and I think what will be the challenge to get this optimization between the demand side, the processing plant and others, and the generation side, the power station and the renewable plant, to actually have the groups internally within the large, you know, miners come together and actually start talking about it, of what's possible and how they can approach this together. And for that, there has to be a need, and a need that we've seen is from shareholders to look at how can you guys decarbonize your operation, and there has to be pressure that makes people move. Because unless people move and we talk to each other, not very much will happen.
And that's obviously one of the key challenges that I think we have, is to build that momentum and keep it moving forwards. What are some of the challenges in terms of storage, do you think, that aren't currently enabling us to realise the full potential of storage?
Oh, well, cost has got to be one. I mean, I think in most applications that we've seen, you know, it is expensive. So I think we need to look at driving down the cost, and I think we've all seen that in PV solar. You know, the cost of solar has come down incredibly in the last couple of years, and so now it's economically viable and competitive in its own right, and I'm sure energy storage will go the same way. And I think in the interim, we just have to look at how we use it and to make maximum use of it, and where it is economically viable, install it, and then each site will build volume on that.
Yeah, and also, I mean, cost is one, I agree. So, you know, the potentially is around, you know, how we package, how we deploy. That's where a lot of savings will come in. But it's also, you know, education. I mean, education about the perception. What does storage do? What can I actually use it for and apply it for? So I think there's a lot of work we need to do, you know, as an industry, and working and with, you know, customers, stakeholders, associations, to explain it just better, what's actually possible with it and what the advantages are. Everyone just sees, you know, batteries and, you know, lifetime and all these sort of things. Well, there's a lot you can do with it if you actually, you know, can extract, in brackets, that value for your plant.
Yeah, I think that's exactly right. I think storage has fallen into the kind of element of buzzword bingo that is like so many other things, and the enemy of storage is actually the word storage in itself, in that not encapsulating that storage is not an end in itself, but a means to a better utilization of both existing fossil assets as well as renewable assets that now, because of the fall of solar cost, renewables have a much lower levelized cost of energy than existing fossil generation assets on site. It just allows for a marriage of these functions, but really, you know, as much as we talk about storage, we need to be talking about control systems, and we need to be talking about you know, the development of intelligence in these related functions as well.
And I think that brings us back to some extent where we started, which is about the ability to adapt, the ability to enable, and I think ultimately integrate the existing offerings, the diesel gensets, the gas, with the new, and actually that incremental approach that I know Jürgen spoke to yesterday is obviously, I think, something that miners are conscious of. How do they fit the new technology, the new contractual arrangements, the new structures in with their existing arrangements, essentially for a better economic outcome? One final question, I think, before we go to the floor is, what are the recent innovations? What's the new stuff coming? And I think with that in mind, how can we alleviate the miners' concerns that early adoption isn't too risky, if at all?
I'd have to say, I've listened to a couple of people today to say that, a lot of the technology is fantastic and it's plug and play and it all works really well, but maybe our experience has been too bleeding edge. But really, often integrating technologies is difficult. Typically, integrating one thing with another might be okay, but when you might have 4 or 5 different technologies coming together to produce the outcome, it's challenging. And I guess that's the part of the industry to keep on working together, as we do with our equipment suppliers and software providers, to look at how to learn from what we've integrated, and the next time it's easier. And there's more and more, particularly software that is an integration layer on one job, but eventually ends up in a piece of equipment that you buy off the shelf. So and it becomes easier for the next project. So I think my take on that is that we need to look at each mine site on its merits, see what's required, assess the risks. You don't want to have too many new technologies coming in at once. And if that can all come together and it looks like a good solution and it's economically viable and the risk is acceptable, our experience is they work. Sometimes it might take a little longer than you think, but it works. And certainly our experience has been customers do get what they were aiming for.
From our perspective, I mean, obviously it is a risk employing new technologies, and what we've tried to do from that standpoint is engage in pilots with companies, and also on our own front. We exist on one of University of Queensland's campuses, actually, and we've built extensive battery banks and the like to run algorithms on site to pre-test prior to moving to pilot. One thing that we also have done is, you mentioned before about networks and retailers not talking to each other. I think we're one of the few companies actually that has Energy Queensland there, as well as Energy Australia, actively communicating about benefits to both parties in the process, as well as Springfield Land Corporation, which is our largest development in the state, as well as Microsoft, as well as all other parties, in a center that we've built for the purpose of these types of discussions, so that our data scientists are actually engaging. And what I'd say, if there are any mining groups that want us to understand their use case better, let's talk about building a pilot where we get you engaged in our data science center as well, where we're specifically tailoring data scientists towards your use case to build out these functionalities so that the risk is lower when integration does occur.
Yeah, I think the term for me as an innovation comes to mind is around simplification. We've got to make this simpler somehow for people to use and adapt. So today we heard a lot about PPAs and how solar PPA versus typical IPP with a diesel power station, how those need to work together. And the same now comes from technology. Fundamentally, we need to demonstrate and package it so it just looks like another generator on the network, and that's it. Don't worry about it, what's behind it. Don't worry about this and that. It's just another generator you can put there, you can take away again, and then it's got a lifetime like every piece of equipment, but that's part of the equation.
And I would agree, and I think 12 months ago I've done a lot in the renewable space over on the East Coast and done a lot of power purchase agreement. 12 months ago we would have said large-scale solar PV was difficult, and now we would say, well, that's just that's our day-to-day job, that's easy. And I think it is about just simplifying things, standardizing at some extent, understanding not just the technologies but also understanding the contractual structures, the financial structures that we can offer, so that quite frankly businesses and industry can do it for themselves. I'm a lawyer, and without wanting to do myself out of a job, I'm a firm believer that the more we can standardise, the more we can reduce advisors' fees, the better we'll all do. And with that, I'll end and open up questions to the floor.
Hi, Jim Lang from FMG. In a former lifetime, I worked in the Congo on a copper mine, which had a wonderful power supply. It cost us all of 6 cents a kilowatt hour, only it tripped about 3 times, 4 times a day, sometimes up to 20 times a day. So we had a full Agrico diesel system to back it up. That was 25 megawatts. And we used to have 20 megawatts of electrowinning with about 4 or 5 megawatts of ancillaries. So we kept 4 or 5 of the diesel gensets running continuously, displacing at a cost of 30 cents a kilowatt hour, approximately 6 or 8 cents a kilowatt hour freebie power off the grid. So what we proposed to do was put in a battery storage system. And we were going to put in a 4 megawatt battery storage system in order to compensate for the ancillaries that remained after we tripped the electrowinning system. There was a lot of concern about exactly what happened in that 15 to 30 milliseconds period when the mains tripped and what the batteries would do and whether they would keep the rest of the load up. Despite the fact that this battery would have paid for itself within about 6 months, I believe that nobody has made a decision on that as yet. And that was about 1.5 years ago that we were promoting this. Seeing as we've got such a wonderfully experienced panel here, I would be very interested to know from you guys as to whether that is a tricky problem or whether it is an easy problem, please.
Well, I have to declare I worked on the other side of this proposal. and it's been interesting. I come back to my last comment. Unless we simplify how this works, it's not going to be easy to convince people to use it. Now, let me put in perspective, the application here is actually quite straightforward, with a mine hanging off a very stringy, very unreliable line. And, that microgrid as such with the critical loads needs to keep going in for certain parts. So we went through a lot of, the typical studies and, what does the sine wave look like and how fast does the protection work and all these sort of things. And what I found is that until we get to a point where consulting engineers, where, EPCs, they become familiar with this type of equipment and what it can do, we have to go through these hoops every time. So from a technical point of view, yes, there would be, a glitch for 50, 100 milliseconds until the fault's cleared and then it operates on its own. But to get that across and to be able to demonstrate that in an environment where people actually have got the same reference is actually still quite difficult. So, beautiful business case, would have loved to do it, but unfortunately, we couldn't convince the right people at the right time. Yes.
And so, look, I'm not an engineer either, but I know our experience is that the battery sets, they're not instantaneous for sure. And in the control systems we've put in place, there's usually 200 or 300 microseconds of handshaking between the various pieces of the system, and I think the battery responds, in its own way. It responds in probably between 500 and 600 milliseconds or something like that. That's my experience.
Maybe
Jürgen's probably more an expert than me.
Yeah. So the concern is not. I mean, the battery can be very fast. That's not the issue. The issue is the time for the. So going one level deeper, but protection to clear, to get rid of the fault upstream, which usually is. So once it's cleared, then the inverter can come in with 5-10 milliseconds. It's very fast. So it's the issue of the system working together in protection settings to make sure the two work well together. Sorry.
It's a whole new education in technology for me too. Any other questions from the floor?
Hi, Ray Massey, Hydro Tasmania. First of all, I just want to make a comment, reinforce a couple of the points made, I guess. And I guess that they're at the either end of the process. John made some comments about it's getting it right, fit for that particular project and the right sort of conditions and what the use patterns is. We have been using utility scale batteries now for a bit over 10 years. Our first foray, the battery lasted 2 years. It was a case of both sides, owner and operator, and I add we're an owner-operator of power systems and hybrid systems as well. at that point in time, both sides of the equation didn't really understand the full goings on. Do by learning experience. Going through time, you see more and more variety of battery suppliers come to the market. And I guess my point, over time, we've seen it's been a process of the battery suppliers themselves trying to get to understand what their product actually is, can do, and the user getting to really understand what they need to ask for. So specification, due diligence is absolutely paramount up front. It's at the front end. And to pick up on a comment of Jürgen's, operators. There's a lot of effort goes into the design, the technologies, the mix, the integration, a lot of people getting together, lots of money. Projects get built, some flags waved, ribbons cut. And then there's another period of about 5, 10, 15 years. We've seen situations where in a fully automated system, the owner-operators weren't brought along on the journey. The operators didn't quite understand what was going on, switched over to manual. All savings pretty much gone. So, again, it's absolutely critical to bring in that complete picture. But I just want to ask a question on the final point there about, Jürgen, you started talking about the response times, and forgive me, those who aren't into the technical sides of the batteries. One of the issues we see for the batteries at the moment is their ability to provide fault currents. For those not aware, that's basically the ability for a rapid high injection of current into the system to clear a fault somewhere else in the grid. And that's fundamentally a safety question because there's a fault in the system and you're talking about people's health and in the system. So what we're seeing at the moment, batteries are supplying maybe 50% over, 100% over, but typical historic generators, several times the amount of current to clear faults and things. I wonder if the panel's got any comments about how the battery side of it, and particularly maybe the inverter side, is tackling that particular issue.
I guess one of the issues that, so we can't provide that function obviously in our aggregate form, but part of the reason for that is because we have to test to Australian standards that restrict us from being able to do so, having anti-island relating functions. I guess in mine sites, if we were able to retest in accordance with that related capability in aggregate or not, that we may be able to attack that problem differently in a surge capacity. But given existing standards, it makes it hard to meet that qualification.
Briefly, Ray, I think I agree today. There is a challenge around that, and that's simply because the distribution system's been designed with those generators supplying into the distribution system. So part of the transformation is obviously changing all the way our distribution systems work, and they might have to then deal with lower fault currents and do it smarter through comms and other things as well. So again, it's that integration process we need to do, make sure things talk to each other and are connected, and then it can work a lot different to what it is today. So it is a bit of a barrier at the moment, I don't disagree, but again, it will change simply because the way the networks operate will change as well.
But I think it's worth focusing on your first point again, Ray, is it? Yeah. That a battery is a battery, so they're probably better now than they've ever been, but it's what you want the battery to do. That's the key thing. And really that's where you have to look at the spec and what the application is, and then design it to be controlled to operate to achieve the objectives that you want. So it's just a battery in a container. Otherwise, it's the control system.
Yeah. No, I'm totally agreeing, but I'm just adding our experience of that learning that had to go on both sides to understand that.
If any other questions, I think there's one at the back.
Thanks. It's Paul Teagle, BAE Systems. I guess the question is, do you see storage enabling or simplifying the penetration of renewables into other industries? It's a bit of a question. I'm in defence industries myself, and this is just at the start of Defence's movement into renewables at remote sites. But I guess, are there other allied industries out there where the storage piece is the last piece of a puzzle as far as renewables go?
I think absolutely. Your requirement would be different again to a miner or a telco or others, but it's the same principles. You know, it's trying to get the penetration and managing that, and energy storage is a key part to control the overall system as it's designed. Absolutely.
But in that example, I mean, you are a different use case, and your customer journey will be different than other use cases. So the implementation of the technology might occur in the first instance, but what you might find over time is that your requirements might be significantly different than a mine or other applications, and that's why that connection to your system and our ability to adjust its capabilities and/or to learn about your usage, to understand that usage, and then to apply other technologies, other IoT-related functions, the ability to aid you in the process moving through and also have you to understand your system better it is important because, again, with many of these use cases being utility use cases, DNSP use cases, use cases for embedded networks, microgrids, et cetera, each of these have different customer journeys. They have different use case as far as consumption and different things that are important, and these things will not be understood until there's a much more granular approach in kind of approaching these related functions. So I think intelligence is really important in this process of understanding industry verticals.
Yeah, I mean, just briefly, fundamentally, the good thing is the industry we're working in, it's either 50 or 60 hertz, right? So the fundamentals are the same wherever we go. And then it's just a matter of working out what's driving it. So one of the things if it comes to taking up renewables as well as storage is, hey, have a look at maybe even storage first, as in storage for stabilizing, because that in itself might already be a business case, and it prepares you then for taking those renewable energies when they come along much easier and with much less risk on board.
Yeah, so a lot of what I've seen in the last couple of days is very close to what we need. Some of it's completely irrelevant, but yeah, there are lots of building blocks in place that I think need to be hooked together intelligently to get the final outcome that we need. Thanks.
I think there's a question at the back.
Hi there, it's Roy Mitchell from One Tide Modular Systems. Just to answer the gentleman's question from BAE, our system just out the back here, our microgrid system, has actually been developed for defence-related industries, and it ties very well into the mining industry, and it sort of ties into some of your comments about keeping things simple. When you're dealing with the defence industry, you have to keep it simple. These power systems have to be operated by people who have no knowledge, or they just need to plug, play, and be very, very simplified. So simplifying things is difficult in the power industry, but we believe we've done quite a good job of simplifying it to the point where you can actually provide a robust system that can go into the field, and it is transferable to the mining industry, because the mining industry needs robust, they need reliable equipment. You get that from defence quality products. So I'll have a chat to the guy when he comes back. Thank you.
Thank you. I think we're out of time for questions, but I would like to thank our panellists. I also like to just kind of 3 takeaway words for me, I think, from the whole 2 days is, 1, around momentum. I think we need to keep the momentum going. I think 2 is about the knowledge and the knowledge sharing. And I think just taking the gentleman's comments is we just need to keep it simple so that more of us can use it more quickly. Thank you.
Thanks a lot, Kelly, John, Philip, and Jürgen. another great session. I'd just like to wrap things up and say thank you to all of our speakers, all of our sponsors, and to all of you. I think it's been a great couple of days. We've sent you the presentation links and the feedback form, and we'll follow up with some photos shortly. So thank you very much, and we look forward to seeing you next year.